Alright, so I'm going to go ahead and cover problem 1 here from the 18.7 section on the Wagner-Whitin algorithm and the silver meal heuristic here. So we're going to determine an optimal production schedule for a 5-period dynamic lot size model with K is $2.50, C is $2, H is $1. Our demand for time 1 is $2.20, demand 2 is $2.80, demand 3 is $3.60, demand 4 is $1.40, and demand 5 is $2.70. And we're going to assume that the initial inventory level is 0 here. So to start off, we're doing a 5-period dynamic lot size here. So we know that at T6 here, we're going to have F sub 6 is going to be 0. We don't want to have any inventory left at the end here. And we're going to be using this general formula, this F sub T equals K plus 2 times D sub T plus F of T plus 1 to incorporate later on here. And as always, we're going to start from the end and work backwards. So we're going to go F sub 5 is going to be equal to, well, our K is just going to be 250 plus 2 times, in this case, D sub 5, which is going to be 270, and then plus F of 6, which we defined as 0. And this is just going to give us 790 here, which 790 is going to be our production for period 5 here. And we keep working backwards to F sub 4. And we need to find the minimum value between, again, K plus 2 times D sub 4, which in this case is 140, plus 790 from using F sub 5 from above. And that's going to equal 1320 here. And then we also have to account for K plus 2 times 140 plus 270 if we produce for period 4 and 5 here. It's 270. And then we have to add on 270 if we do it this way, plus F sub 6, which is going to be 0 here. And this ends up totaling out to 1340. So obviously 1320 is lower, and that is our production for period 4. Then we have F sub 3, which is going to be the minimum of, we can do 250 plus 2 times the demand, which is 360 here, plus that 1320 from above, which gives us 2990. We could also do, if we produce for period 3 and period 4 here, 2 times 360 plus 140, and then adding on that 140, and then plus that 790 from F sub 5. And that's going to give us 2180 here. Or we could produce for periods 3, 4, and 5 here, which then we're going to have is 2 times 360 plus 140 plus 270. Now, with this part, since we're doing it for 2 future periods, we do 140 alone, but then we have to do 2 times the period 2 time points away. And then we add 0 here for that F sub 6, which gives us 2470. And again, between these 3 here, this is going to be our lowest. And our production for period 3. Moving back one step further, we have F sub 2, which is going to be the minimum of, if we just do period 2, it's 250 times 2 times 280. And then we add on that 2180 from F sub 3. And that is going to sum to 2990. Or we could produce for periods 2 and 3, which would be 250 plus 2 times 280 plus 360 for the 2 demands there. Add that 360 on at the end, and then take F sub 4, which would be 1320. And summing these will give us 3210. If we produce for periods 2, 3, and 4 here, we have 250 plus 2 times 280 plus 360 plus 140. Now we add on that 360 plus 2 times 140. And then we have to add on our F sub, what is it, F sub 5 here? Yeah, which is 790. And this all added together is going to give us 3240. And then finally, if we produce for periods 2, 3, 4, and 5, we are going to have 250 plus 2 times 280 plus 360 plus 140 plus 270. Then we have to add on 360 plus 2 times 140 plus 3 times 270. And then add on, it's going to be F sub 6, which would be 0. And that's going to give us a total of 3,800. And between these four values here, the 2990 is going to be our lowest and our production for period 2. And let me see here. Then we have to do F sub 1, which is our final computation here for our first period. We need to find the minimum of, if we just do for period 1, 250 plus 2 times 220 plus 2990 from one above here. It's going to be 3680. If we do period 1 and 2, we have 250 plus 2 times 220 plus 280 for the two demands. And then we add on 2180 from F sub 3, and that's going to equal 3710. If we do periods 1, 2, and 3, we have 250 plus 2 times 220 plus 280 plus 360 plus 280. Actually, I made a mistake right here. It should be 220 plus 280 plus 280 again here, plus 2180 equals 3710. This here we're adding on 280, then we have to do 2 times 360 plus 1320 for F sub 4, and that's going to equal 4290. If we produce for periods 1 through 4, it's going to be 250 plus 2 times 220 plus 280 plus 360 plus 140. And then we have to add on 280 plus 2 times 360 plus 3 times 140 plus 790 for period F sub 5. That equals 4460. And then lastly, if we do all the periods at once here, we have 250 plus 2 times 220 plus 280 plus 360 plus 140 plus 270. Then we add on 280 plus 2 times 360 plus 3 times 140 plus 4 times 270 plus F sub 6, which is just 0. That's going to equal 5290. And amongst these 5 options here, our lowest is going to be 3680, which is our production for period 1. So now we can see our total cost here is going to be equal to F sub 1, which just means we're going to be paying a total of 3680. And to get this, we're going to produce 220 units in period 1. Then we're going to go to, if we're just producing for period 1, we're going to go up here, and just producing for period 2, we're going to make what would it be, 280 units in period 2. Then up to, for period 3, we need to make 500 because we're going to do production for 3 and 4. And then since we made our production for period 4 and period 3, all we have to do is the 270 we need in period 5. So this is going to be the most cost-effective way to produce our units of production we need in the least amount of cost. Thank you.